Now let's talk about graphing rational functions. The first thing we want to do is to find the y-intercept. Let's take 0, put it in for every x that you see. That'll give us a y-intercept. The second thing that we'll do is to find a vertical asymptote. Vertical asymptotes occur at the restrictions from the domain, so we'll find those by taking the denominator, or the bottom, of our fraction, setting it equal to 0 and solving. Horizontal asymptotes come from comparing the degree of the top with the degree of the bottom. We did another video where those are explained. The next thing to do is the X Intercept. For a fraction, if you take the top and set it equal to 0 and solve from there, this will give us the X Intercept. All we need is the top of the fraction. If you can't get the picture yet, do some extra points, and if you pick numbers that are close to the vertical asymptotes, it'll give you the best possible arithmetic. One more tip for getting your picture: there can be no wine glass shapes on your picture. What I mean by that, a picture like this one could never happen where we have a shape that appears to be the stem of a wine glass. You can never have two parts of a rational function side by side on that vertical asymptote. This can never happen with rational functions. For a rational function, the two parts have to be diagonal to each other. They cannot be side by side. Let's look at an example of finding each of these things. For the first problem, if we want to find a y-intercept, let's put 0 in for all of the x's and see what's left. If I do that, I'm left with 1 over negative 1, so our y-intercept is going to be at negative 1. There it is. The vertical asymptote comes from taking the bottom, set equal to 0 and solving, so x equals 1 is our vertical asymptote. Remember that asymptotes are represented with dotted lines, and x equals a number. That's how you represent a vertical asymptote. Horizontal asymptotes come from comparing the degrees. The degree on top was 1. The degree on bottom is also 1. So for this problem, ratio of leading coefficients, our horizontal asymptote is 1 over 1. Leading coefficient from top divided by leading coefficient on bottom. 1 over 1 makes 1. So our horizontal asymptote is here at y equals 1. Horizontal lines are always y equals a number. The next thing to do is the x-intercept. That comes by taking the top, set equal to 0. If I take the top and set it equal to 0, looks like negative 1 would be our x-intercept. So negative 1, 0 will be a point that's part of our picture. Now I can already tell what that side is going to look like. I've got to approach each of the asymptotes without crossing them and getting close to each one of them. So there is that side of our picture. The two parts of the picture are always diagonal to each other, so I know the rest of the picture has to be up here to keep us from getting a wine glass shape. If you weren't certain of that, you could substitute 2 in and see what you get. If I take 2 and put it on top, 2 plus 1 makes 3. If I put 2 on the bottom, 2 minus 1 makes 1. So this would give me a value of 3. 3 is clearly up there in that area, so it looks like we've got the right picture. Let's look at another one and determine just each of these important parts. We won't try to graph them. First, the y-intercept. 0 for all of our x's makes this go away. 1 over negative 1, 0, negative 1 is my y-intercept. This particular problem, since I've got a square on the bottom, I'll need to factor as much as I can and set the factors individually equal to 0 to determine what our vertical asymptotes are going to be. From this factor, I get x equals negative 1. From the other factor, I get x equals positive 1. So this one has two separate vertical asymptotes. My horizontal comes from comparing the degrees. With a degree of 0 on top, the top is less than the bottom. This is always y equals 0 when we have top degree less than bottom. For this particular problem, 1 on the top cannot equal 0. Since this makes no sense, there is no x-intercept possible. The top set equal to 0 gives us an x-intercept. When it's something that can't happen, then there is no x-intercept. We could draw the picture from there. Whenever you want to try to draw a rational function, first find the y-intercept by putting 0 in for all the x's. Next, find the vertical asymptote. That's the bottom set equal to 0. Horizontal asymptotes come from comparing the degree of the top with the degree of the bottom. X-intercepts come from setting the top equal to 0.